Have you ever found yourself stuck trying to figure out if a template specialization exists in your code? It can be quite the puzzle, right? If that's you, then you're in the right place. Today, we're diving into how to determine if a certain template specialization exists, even when the general case is not defined. I totally get it. It can be frustrating when you're trying to write clean and efficient code, but you're not sure if a specific template specialization is available. You're definitely not alone in this struggle. Many developers face this challenge. Here's the specific situation we're looking at. One user recently asked, "How can I check if a certain template specialization exists when the general case is not defined?" They provided a code snippet that defines a general template and a specialization for integers. Sound familiar? If so, let's explore this together and find a solution. So what exactly is the issue here? The user wants to define a struct that checks if a specialization exists for a given type. This is a common scenario in template metaprogramming, and understanding how to handle it is crucial for writing robust C++ code. And don't go anywhere. I've got a clever trick at the end that will help you master template specialization checks in no time. To determine if a template specialization exists, the user can utilize a technique involving partial specialization. First, we will define a primary template for our struct isDefined. Next, the user should create a partial specialization of isDefined for the case when t is int. This will allow us to check if aint is defined. Now the user needs to define a fallback specialization for all other types. This will set the value to false if aat is not defined. Finally, the user can test the implementation by checking the value of isDefined for different types. This will confirm whether the specialization exists. Fun fact, did you know that C++ templates are a powerful feature that allows for generic programming? They can be a bit tricky, but once you get the hang of them, they can save you a lot of time and effort. Now let's look at the answers provided by other users. This user offers an alternative implementation using a technique similar to one previously mentioned. In C++11, they define a struct called isCompleteType, which checks if a type is complete. If the type is complete, it returns true. Otherwise, it returns false. They also provide a tentative C++03 version, but it does not work due to an error in template parameter deduction. The error indicates that the template parameters cannot be deduced in partial specialization. Here's the clever trick I promised. By using sFiNA, you can create a robust check for template specializations that will work seamlessly in your code. This technique is a game changer for template metaprogramming. And there you have it. You now know how to check if a template specialization exists in C++. Remember, mastering these techniques will make you a more effective C++ developer. If you found this helpful, hit the subscribe button for more tips. And don't miss our next video on advanced template metaprogramming.